Relox.
And I am Enrico.
And we are the developers of the PALAY dryer padding machine.
Introduction. We all know that the production of rice includes drying, in which farmers are utilizing the sun drying technique. It is an old age technique preferred by many of us because it is the least costly that is usually done by the family members. There are several options for sun drying: field drying, mechanical drying, drying on nets, mats or canvas, and drying in pavements. Using this option for sun drying requires a little investment and is environmental friendly. From the problems encountered from the traditional sun drying, the researchers think of ways to improve and reduce these issues by developing the PALAY dryer padding machine.
Objectives of the study: design a circuit that will automate the manual way of padding and drying of PALAY. Developing a padding machine using microcontroller to improve the traditional way of sun drying PALAY. Evaluate the project in terms of reliability, functionality, ease of use, and safety.
Significance of the study. First, farmers. It will benefit the farmers to easily dry PALAY seeds in automated way. Number 2, rice mill owners. It will help the rice mill owners to minimize the manpower, labor, and save more money for other expenses. Number 3, future researchers and developers. Through this study, the future researchers can have their ideas in building a new project related to this. It can also help them to have a basis in building much advanced technology and appropriate materials to be used.
Scopes and limitations. The project focuses only in a padding of PALAY. The machine will automatically pads from time to time based on the user's set time interval. The users also set distance and rows to be pad so that the machine can start to pad automatically in vertical way and vice versa.
Definition of terms. First, wiper motor is an electric motor that moves the windshield wiper. This type of motor was used by the researchers in making the PALAY dryer padding machine. Next, Arduino is an open source electronic platform or board that uses software to program it. This board serves as the main brain of this project. It is responsible in the whole execution and control of the whole project, such as sensor and motors. Liquid crystal display is useful for creating a standalone project. This LCD display are typically used to view information or servers as a small monitor of the system. This component is used to provide a display and to communicate with the PALAY dryer padding machine. Potentiometer is a 3-terminal resistor with a sliding or rotating contact that forms an adjustable voltage driver. This component is used to control the angle of the wiper motor for the left and right movement of the machine. Next, compass is an instrument used for navigation and orientation that shows direction relative to the geographic cardinal directions. This component is used for checking and maintaining the right position of the robot.
Chapter 2. Review of related literature and studies. Foreign literature. First, development of a cyclone rice dryer, according to School of Engineering, September 2009. Next is the basic concepts in rice drying research, according to PubMed, November 2007. Next is seed spreading robot, according to Instructables 2009. Local literature. First is the development of automatic rice grain dryer, according to Journal of Computing and Innovation, GCI, Volume 2, Issue 2 for April 2018. Next is the paddy drying, Journal of Knowledge Bank, Post-Harvest, Unit CESD International Rice Research Institute or IRI, version 2, October 2013. Foreign studies. Best practices for paddy drying. The study of Tran Van Tuan, the year 2009. Next is the automated steering robot or ASTRO, the study of James Dyson, in the year 2016. Local studies. The case of rice and corn drying in the Philippines. The study of Michael Gragasin in the year 2011.
Technology use. Arduino. It is used as the main controller of the system. Keypad module. It is used for the inputs of data. SketchUp. It is used for the designing of the appearance of the project. Arduino Integrated Development Environment, or the IDE. It is used for the programming purposes of the project. Liquid Crystal Display. It is used as the graphical user interface of the system. Compass. It is used for the navigation of the project.
Conceptual framework. The figure shows the process of PALAY dryer padding machine. The keypad module is used for the input of data like distance, rows to be pad, and time interval of the process. The Arduino is for executing the program of the machine. Then the compass is for maintaining the right position of the machine. Then the wiper motor moves forward, left and right. Then the process will go back to the keypad module to execute the time-to-time interval process.
Conceptual paradigm. For the conceptual paradigm, these are include the input, the process, and the output. For the input, number 1 is the knowledge requirement. Number 2, hardware, which are the Arduino board, wiper motor, compass module, the potentiometer, the keypad module, the LCD, and the laptop. For the software, we use the Arduino IDE. Next is for the process. Process are problem identification, research, requirement specification, concept generation, design or the system flow, prototyping and constructing, the system test, and the system integration, and lastly, the evaluation. For the output, the researcher developed the PALAY dryer padding machine.
Chapter 3, Methodology. Descriptive overview of the design process by Ralph M. Ford and Chris S. Colston. The project concept, specification, and requirements are illustrated and evaluated to ensure the effectiveness and uses of every essential detail to meet the success of the study. Methods and procedures are based on the engineering design process formulated by Ralph M. Ford and Chris S. Colston in the year 2008 that was proven to be effective in the design process.
Problem identification. Temperature control is the main problem to be solved by the project because studies have shown that overheated grades can result in low milling quality caused by the cracked grades. Number 2, farmers waste more time and get tired of padding the PALAY from time to time. Research. The researchers conduct research and gathered more suitable information about the project. The researchers spent a lot of time in browsing into the internet to find existing project that is related to the proposed project. 3. The researchers also search for different project circuitry and diagram that can serve as references or basis about the project. Requirements specification. The researchers have discussed, decided, and specified the function and the task of the project. The purpose of the project is to pad the PALAY automatically with a certain distance, row, and time interval. The researchers decided to build a 4-wheeled robot that have a capability to pad PALAY. A lot of motors with high torque will also be used from the above-mentioned projects. Concept generation. One of the ideas that the researchers considered was to build a 4-wheeled robot that have a compass to determine the correct direction of padding. In terms of time-to-time padding, they will set it up with the use of the keypad module.
Design phase. Block diagram of PALAY drying padding machine. This diagram shows the process of the project. It begins with the keypad to set distance, row, and time interval that serve as an input. It is controlled by the microcontroller, which gives signal to the compass to give the right position or direction to the machine. Then, the motor will start rotating for the forward, left and right movement of the machine. Figure 5 shows how the project will function depending on the situation. First, the user will open the main switch to power up the system. Then, the user will enter distance, rows, and time interval. If the user accidentally press a wrong keys, he will press asterisk to set up again. Then after setting up, the robot will start on moving. The robot will measure distance traveled. If the distance traveled equal to the set distance, robot will stop and turn right and checks its initial position. Once the robot is in its initial position, it will move forward and check again the distance traveled. If the distance traveled equal to the set distance, robot will stop and turn left. The routine continues again and again depending on the rows entered. If the rows entered match the current rows, the robot will stop and wait for the interval. The robot will stay on its steady state once the set interval equals the current time. Press the hashtag to stop the process of padding and return back to the setting up of the parameter.
Mechanical section. Figure 6 showed the schematic diagram of the PALAY dryer padding machine. The connection of the components that will be used are shown. The Arduino Uno is used to command signal on the Arduino Mega on turning right and turning left. The potentiometer is used to navigate the wheels on the desired angle, which is connected to the Arduino Uno DCC, ground, and analog 0. The Arduino Mega is the main brain of the project. A 3x4 keypad matrix is used in entering parameter, which is connected on the Arduino Mega digital input. A 20x4 LCD is used as the graphical user interface of the system, which is connected to the SDA and SEN. Compass module is used to check the initial position of the robot, which is connected also to the SDA and SEL. The system is powered up by the 12 volts battery supply and being charged through the use of the 12 volt solar panel, which is connected to the solar charger controller.
Project design. Figure 7 shows the isolated view of the PALAY dryer padding machine. Figure 8 shows the front view of the PALAY dryer padding machine. Figure 9 shows the rear view of the PALAY dryer padding machine. Figure 10 shows the top view of the PALAY dryer padding machine.
Prototype and construction. The researchers search for different ideas to construct the best prototype of the project. They look for the different classification of motors and actuators with a higher torque. They also look for the battery that would supply the whole circuitry. System integration. To get the correct output of the project, the researchers will use an Arduino IDE to program the PALAY dryer padding machine. A lot of troubleshooting and calibrating of different material were done. Through this, the researchers developed the PALAY dryer padding machine. System test. PALAY dryer padding machine had undergone different system tests. The researchers tested different processes on how it works properly and appropriately. Through research and development, the researchers were able to get the desired output.
Evaluating the project. The following rating scale will be used: 5 for excellent, 4 for very good, 3 for good, 2 for fair, and 1 for poor to determine the quality of the project. Table 1 shows the rate of evaluation.
Chapter 4. Design and Development, Testing, and Analysis Result. Evaluation of existing method. The researchers considered the existing old method of padding PALAY to attain the required specification of the PALAY dryer padding machine. This helped a lot in the success of this project. Design consideration. During the planning stage, some matters were taken into consideration. Design consideration. During the planning stage, some matters were taken into consideration. This includes the cost, specifications, and the availability of the materials used, especially in dealing with the newly encountered material like the wiper motors. Likewise, the reliability, functionality, ease of use, and safety were also taken into consideration.
Electronic assembly. Figure 11, the circuitry. Figure 11 shows the circuitry of the PALAY dryer padding machine. Mechanical assembly. Figure 12, PALAY dryer padding machine. Figure 12 shows the finalized design of the PALAY dryer padding machine. The wiper motor connected at the back wheel. Figure 14 shows the wiper motor at the back part of the machine for the forward movement of the device.
Hardware process. The hardware process involves the procedures and instruction and operation of the system. The PALAY dryer padding machine has a switch that serves as the main switch of the system. When the switch is turned on, the system will automatically power up the machine. The researchers use an LCD as a graphical user interface and a keypad module to set the distance in rows and the time interval to be padded by the machine. It uses a 12 volts battery supply for the two wiper motors. The first wiper motor is for the moving forward and the other one is for the turning right or turning left. The two wiper motors are connected into the relays. The compass sensor is connected directly to the 5 volts pin of the Arduino Mega and the SDA and the SCL of the Arduino Mega. Fabrication of the mechanical parts and interfacing of the electronic control. This part involves considering proper material used during the fabrication of the PALAY dryer padding machine. The safety of the device was first prioritized by the researchers because most of the components used are electronic and must not be exposed to heat to avoid for any electrical problem. A sensitive sensor was placed in a way that it couldn't be affected with the vibration of the machine whenever it is moving. The researchers used a potentiometer to control the wiper motors for turning right and turning left, and a forward movement for the device.
Simulation, testing, and troubleshooting. The simulation of this design project was through the help of the Arduino IDE in calibrating the different sensors used in the machine. Testing activities were done in all components to identify if there was any problem or failure according to the desired specification. The troubleshooting was done on the problems encountered during the development of the project. Most of the problems were about the inconsistency in the value of the sensors, texture of the field, wheel, and motor. Project testing. To ensure the effectiveness of the project, the PALAY dryer padding machine was tested several times. Different commands were also used in most of the materials to get the right output. Laptop was used to monitor the sensitivity of the sensors.
Table 2. Evaluation were given to the 30 evaluators, who are composed of 10 students and 20 communities. The project was rated based on the following criteria: reliability, functionality, ease of use, and safety, with a scale of 5, which is excellent, 4 as very good, 3 as good, 2 as fair, and 1 for poor. The project was rated excellence in terms of reliability, functionality, ease of use, and safety, with the overall weighted mean of 4.7, which is excellent. Established, the project was reliable, functional, easy to use, and safe.
Figure 15. Summary and result of the evaluation. The figure shows the summary and result of evaluation for PALAY dryer padding machine. The project's reliability was rated as excellent of 83.3% of the respondents and very good by the remaining 16.7%. The project's functionality was rated as excellent by the 76.7% of the respondents and very good by the remaining 23.3% of them. 66.7% of the respondents rated the project's ease of use as excellent, and the remaining 33.2% rated it very good. Lastly, the project safety was rated by the respondent as excellent with 63.3%, very good with 33.3%, and good with 3.3%.
Computed mean for the reliability of the project. Out of 30 respondents, 25 rated the project as excellent and 5 for very good. The calculated mean of 4.83 was interpreted as excellent. Computed mean for the functionality of the project. Table 6. Out of 30 respondents, 23 rated the project as excellent and 7 as very good. The calculated mean of 4.77 was interpreted as excellent. Computed mean for the ease of use of the project. Table 7. Out of 30 respondents, 20 rated the project as excellent and 10 as very good. The calculated mean of 4.67 was interpreted as excellent. Computed mean for the safety of the project. Table 8. Out of 30 respondents, 19 rated the project as excellent, 10 as very good, and 1 as good. The calculated mean of 4.6 was interpreted as excellent.
Chapter 5. Summary of findings, conclusions, and recommendations. Findings. Number 1. There is a conflict when using 3 or more I2C communication in Arduino Mega. So the researchers lessened the use number of I2C to make it well. Number 2. When compass is near a metal, there is a failure on reading direction. So the researchers decided to place the compass sensor far from metal to protect it from inconsistency. Number 3. Due to too much vibration, the compass will hinder the accuracy of the sensor, so the developers place the sensor on the part that it will not affect by too much vibration in order to function accurate. Number 4. Using a wheel without spike will affect the pattern of padding the PALAY, so the machine used spike wheel in order to make the pattern well. Conclusion. Based on the summary of the findings and evaluation of the project, the researchers had concluded that number 1. The PALAY dryer padding machine is designed to fully automate PALAY padding. Number 2. The machine was developed using microcontroller and sensor powered by batteries that are rechargeable by solar energy. It can improve the way of PALAY drying. Number 3. The machine was evaluated as reliable, functional, easy to use, and safe. Recommendation. The following recommendations were suggested by the researchers and evaluators. Number 1. Check on the specification of the materials to be used to avoid incompatibility on each material. Number 2. Produce good casing on the prototype, especially on the circuit parts, to avoid any damage. Number 3. Choose appropriate wheel or tire so that the machine pads PALAY properly. Number 4. Put the compass sensor far from metal to avoid problem on the sensitivity of the sensor. Number 5. The wiper motor should be installed properly for the padding phases of the machine.
First, turn on the main switch. Upon entering the desired parameter, note that our system only accepts a 2-digit input. If ever the user will use a single-digit input, add 0 first, then your desired number. If ever the user put a wrong number, just press the asterisk to set up again. As you can see, the system is asking for setting up again. So, let's start. First, measure how long is the field to be pad. Then, enter the distance in meter. Then, set how many loops would it take to cover all the rows of the field. Last, set time interval for checking the time-to-time padding, including hours, minutes, and seconds.
That's all for our project. Thank you for watching.